Hello everyone, welcome back to the channel Coding at Home, where we learn how to program in the Unreal Engine. So this is part 2 of the AI boats floating on the water, and way paths, avoidance, all that good stuff. So I'll move my face out the way, over here, down there, and I will simulate what we are going to achieve today. So I'll let you have a little look first. You can see, I'll tell you what, we'll do another simulation so we get another random location, see if we get a bit of a trickier one. Typical. Okay, let's do another one. That's a bit better. So, what we've got here is a waypoints that have been found along the path using a navmesh, which is on the floor of the waterbed, so the landscape. It's found them. I've raised them up to the top of the water level, and the boat is now moving to each one of them points using physics, not AI move to or anything in that respect. And it's finding its way to the final target there. Now, at the minute, it's going to come up with a load of errors because it's trying to go back to the start and then find its way to that point. But what we're going to do, we'll make this now. I'll make a part 3 and tidy up all them little bits and pieces and start the new waypoint from the current location and stuff like that. But okay, let's build this one for now. So what we'll do, I'll move that out of the way. Now, this is where we got to on part 1. If you haven't seen part 1, where we build the boat, get basic movement, go back and watch that one. I'll put a link in the description. Follow along, get to this point, come back, and then we'll start adding and changing what we've got so far. So, first things I want to do is show you if we have an AI boat and we do an event tick. And what I want to do here, this is just for debugging to show you something, what's going on. I want to get the velocity, and that's going to be physics linear velocity of the boat. Then we're going to get the length, the vector length, and we're going to print that to a string. Okay. This is essentially this is getting the speed of the boat. And I mentioned in the last video what's happening is you can see it's getting, well, wait till it settles. It's 500s of speed, and it's getting more and more and more as it'll just keep getting faster and faster and faster. So first thing I want to do is I want to show you a little bit of code so we can cap that at the speed. Okay, so it stays consistent, which is very straightforward actually. So we'll get rid of that tick. Well, we'll leave it on for a second so you can visually see it. So in our AI boat on the move to event, we basically need to just drag this out a little bit more. Instead of adding the force, we want to get another boat here. We want to set it's going to be set the physics linear velocity, which is what we're getting here. So we're getting the linear velocity. Now we want to set the linear, if I can talk properly, linear velocity. And what we want to set that to is the force that we've got. Now we want to know when we want to set that. So we want to come here. Actually, I think we need to be in here. We need to get the physics linear velocity of the boat. Okay, then we'll need to get the length. I think you don't need to type get, you need, it's vector length, isn't it? Like that. And now we need to ask it, let's give ourselves a bit more space here. We need to ask it, is that more than the speed? okay, which is what we want it to be. If that is not, we want to add force and run our normal graph of what we already had. Now, if it is more than speed, now, so we've started at 0 knots, for example, and we've added the force till we've got to that point. We're then going to set the speed, which is coming off of here. What we'll do, tidy this up so we can all see what's going on, and it looks a little bit neater. So we're doing the speed times, so we're either going to add or keep consistent when we're up to top speed, and then we will just call the delay and the move to again, and add to current, leave unchecked. So if we now compile and save and simulate, once the boat is in the water and is doing a move to event, you can see it gets to about 500 and then caps. So it's now staying at that consistent speed. So if we jump out and we go to speed, and for example we set that to 2000, it'll accelerate up to 2000 and then stay at 2000 consistently. It'll never go faster than that, which is quite a fast speed. Okay, so what we'll do is drop the speed back to 500 and get rid of that debug now. Oh, we've done that, seen that. Did I change anything here? Because I was playing around with that for a little bit. No, that looks okay. So what do we want first? Okay, so we need to bring in a nav mesh on our island. So what we're going to do here, I'm going to move this island out the way best we can, just because it's actually in the way, isn't it, really? Just put that right in the corner. Don't worry about that landscape. It's the water. It's just the way it's rendering. So we need now volume, nav mesh bounds. Bring one of them in here. We'll zero out the location. Scroll down to the box. Bring that up. And drag that out. Drag that out there. So we're roughly the size of the landscape. Okay. It's picking up the old island location. For some reason it thinks it's back over there, so do we need to worry about that? No, I think because we're going to rebuild the paths now anyway. The second thing I want to do is get the trigger box volume, and we're going to delete that now because we're going to spawn the target in a different way. So because if we don't want, we're going to put some obstacles in the way, we don't want the target to spawn on an obstacle. So we're going to delete that now. We've created a nav mesh. So let's now create a blueprint actor, call this island or obstacle or whatever you fancy. Open that up, we'll add a cube, click OK, and we'll drag him in, and we'll set the scale, we'll lock the scale and maybe set this to 20, maybe a little bit bigger, 40, save, compile, something like that. Okay, drag him down, and what we'll do is we'll make sure it's going through the nav mesh there. What I have done, which I forgot to mention, if you click on your water in the water body and scroll down to rendering, and there's a little drop here under water processing. If you untick, drop that down and untick enabled, all that's doing is just turning the water off, just so we can see what's going on. And then you can also, if you go underneath your water body ocean, you've got the actual water body mesh. If you click the little eye on that, you can turn that off, just so we can see what's going on a little bit easier. Because the size of our boat is far too big to be this close to an island. So what we want to do is, we want to make the nav mesh have it's a little setting that's called agent radius, and we're going to make that a lot bigger so it gives more room around obstacles. And the way we're going to do that is, if you go into your edit project settings, drop down to navigation mesh here under landscape, and you can add agent radius. Yours will probably be at 35 or 34, something like that. Set this to 1000. Close out your project settings, go back to your world default, and then it'll refresh like that. In your world outliner, when you're using a nav mesh, you'll get the actual nav mesh, and then you'll get the recast nav mesh default. This is what draws it visually and generates the nav mesh, and this is where you can change some settings. So what you might need to do is come into your recast in the details panel, and the agent radius, if that's still at 34 or 35, change that to 1002, and then click build your paths. So you should get something looking very similar to this now. And if we want, we can now drag out some obstacles in the world like so. What I'd be aware of is you would be probably a bad idea to put them something like that, where you've got like a very thin path. It should work fine, but for now we don't want to have any more problems. Just either have them all the way off or give yourself some room there. Have another here, another here, and then some more up the top here. Okay, so what we want now is the target ball to spawn in. Now, the way we did that before was through the trigger box, find the location, and there spawn it. That's not going to work anymore. What we need to do is find a location that's on the nav mesh, that is, so it's not going to spawn on an island or something in that respect. So we had the boat AI spawn the target. So we no longer want to get all actors of class trigger box. So we can now delete this bit of code here. Bring this a little bit closer back now. What we want to do is drag off the location, and we want a random point in negotiable, I think you'd say, radius, navigable radius. Okay, so the origin, well, we know the origin, we can just split that, it's at 0, 0, 0. And the radius, this can be a massive number just to cover the whole area, so 50,000. And then we can spawn that target. Okay. That should now, we'll do a little test. Yeah, so that's spawned in over there now. We'll do a stop. We'll do another little test. That's spawning over there now. So it's in the nav mesh, and it's in a reachable point. So, for example, it's not going to spawn anywhere on the island because there's no nav mesh here. There could possibly be a chance of it spawning on the top. So what we could do, so we just grabbed our nav mesh here and maybe just lowered that to the point where it's covering the land, the actual landscape, but not on top of the islands, just to avoid any issues in that respect. And what we'll do, just to copy what we have in the project, if you come in, click your sphere, basic ships, and you should have starter content enabled, and then you just change that to a color. So this is the point at which we want to find a path to. So let's play a stop there. Okay, so now what have we got next? We need waypoints. Okay, so let's add actor waypoint, and you want to add a sphere again. We'll make this one a little bit smaller at 0.6 or so. Not 0.6, that's 6 in total for all the X, Y, and Z. And we'll drag one in just to check the size of that. Put the water back on. That could probably be a little bit smaller. Sorry, I've dragged in the target ball there. Yeah, maybe a little bit smaller. Go to 5. And we'll make the color of that one red. Save. Now what we want to do in here is the same as the target ball. So if we just highlight, Control C, come back to the waypoint, Control V, and we want to set its location. Okay, and that's pretty much done. I think we need to come to the sphere and then go to collision. And I think I had this at custom. It's a world dynamic, but we want to query only, just so the boat, when it gets to it, it doesn't collide with it, but we want to know, is it overlapping? So we'll do all overlapping, and it's a query only, so there's no physical bumping into it. And then we can compile, save, and the waypoint I think we are finished with. Let's double check. Yeah, so the waypoint is finished. Okay, so we can get rid of that now and that now. And we can jump back into the target ball. So the way this is going to work is we're going to spawn a character. It's just going to be an empty character with no collision, and we want to spawn it on the landscape. And then that character will find a character that the boat's going to spawn, as if they are walking on the bed of the water, or the landscape, like the sea floor. And then we're going to raise that path to the sea level for the boat to then copy. Okay, so what we want to do first is, if you come into your project settings and you want to go to, in the engine tab, go to collision. I'll remove mine, so if you can copy along. You'll have an object channel and a trace channel. What you want to do is an object channel, because the landscape's an object, it's an actor, so to speak. So you can click new object channel, name it landscape, click accept on block all. Now you can remove that. So when we come out of here and click our landscape, we can come down in the details panel, find collision, and mine's already done, but yours will probably say world static and block all. That's probably what yours will look like. So you want open up collision presets, change that to custom. You want collision enabled, and you want to change the object type to the object type we've just created, landscape. And of course, block hole should be preset for you. So now, when we are in our target ball, we can do a line trace, and it's a line trace for objects. And then we're going to drag off objects, and we're going to say make array, and this is an array of all the objects it's going to look for. So it'll ignore everything else unless it's in this list. And we want it to only look for landscape. Ignore the water, ignore anything else that's underneath there. So it just go straight until you hit a landscape or until you don't hit a landscape. So we want now to set where this wants to trace. So we want to get the actor location. So we want it to start at where we are. Okay. And we want it to now end at. So this is, imagine you're the target ball. We want to do a line trace straight down till we hit the floor of the ocean. So the way we want to do that is if we get the actor up vector. So you can have an up vector and a right vector. And the way you can quite easily do, there's no get actor down vector. What you would do is get the up and then use a negative number to go down. Now I'll show you that now. So what we're going to do is we're going to get the actor up vector. We're going to do a multiplication by float. And this is the length of how far down you want to go. So we know our ocean depth is at 1,000 or 2,000 units deep. So you want to go at least past that point. So if your ocean's 10,000 units deep and you've got quite a big ocean, then you'll need to go at 10,000 or more. So what I'm going to do is a nice round number, 5,000. And of course this wants to be minus 5,000 because we're going down. Now with this value, we want to add vector plus vector. And we're going to add this value to our actor location. Now this value plus this value with minus 5,000 will give us the end point. And what we'll do is we'll put that to persistent so you can see it. So we'll go into here, we'll go here, and we'll press simulate. We'll turn off the water so we can see, not that one, the mesh actor. And now you can see the target ball has done a line trace, and you can see it's like a square. That's the hit point. You see where it's hit the landscape and then it's gone green. Okay, so now we know where the landscape is on the nav mesh. What we want to do is we're now going to need a blueprint class type character. And we're going to call this AI Pathfinder. Okay. Open this guy up. Leave everything as standard in that respect here. All you want to do is come over to the capsule component, come down to collision presets is pawn. Just click that drop down and go no collision, because it doesn't need any collision. It's not having an effect on the world. Click compile and save. Now let me just double check. Do I need any information in there? No, that's completely blank. So that can be closed out. So now we've got our point and now we've got our character. We're going to go back into the target ball and we're going to drag off this out hits value. And we are going to break the hit result, drop down, and we're going to say, we're going to do some checks. So if blocking hit is true, that means it's hit something. If it's false, we're going to print string so we know what's going on, and we're going to say line trace did not hit any landscape, like so. Now what we want to do, if it has hit the landscape, is we want to spawn actor from class, and this is going to be the AI Pathfinder actor that we've just created. Now we're going to open a transform here. We're going to split that. So a transform is the location, rotation, and scale of an actor or object. We want the collision handling override. Just put always spawn, ignore collisions, just so it spawns where we want it to spawn. The location is the hit location from the line trace. So we're going to drag that along and pump that into the location. Okay, now what we can do is we can test that if we actually just come back into your Pathfinder, and if it doesn't look like this, just open the full blueprint. I'll open it just in case yours does look like that. We're not doing anything in here. All I want to do is click on the capsule component, and where it says rendering, I want hidden in game to be false, just so we can see what's going on. We always want to, when we're creating stuff, you want to see what's happening. So if it's something's wrong or not working, you've got the visual side of things that might help you out to fix your problem. Okay, so we're going to make that visible, and we're going to close that out. Now if we click simulate, wait for the boat to settle down. So there's our target spawned over here. What we'll do is we'll turn the water off so we can see, and I'll zoom right in here, and now you can see there is the capsule components being spawned on the landscape in the nav mesh. So that's brilliant. That's what we want. Okay, so we can press stop, open up the target ball, the island that can be closed, we don't need that open, the target ball. So now we've got this AI Pathfinder, which is a character in respect. We're going to promote that to a variable, and we're going to name that AI Pathfinder ball target. Okay, you can name that whatever you want, just name it so you know what it is. So it's the target side, because the boat is also going to spawn one, so you want the reference to be maybe slightly named different, you know. Okay, now that is all we need in here, so we can close that out, I believe. Yes, now we're in the boat. So what I've done in here on the event begin play is we'll move this over here, and we'll give ourselves some more room. So before we spawn the target, we'll move this out the way for a second. What we're going to do is the same as the target ball. We're going to spawn an AI Pathfinder, which is our character actor, with a line trace, and so it's mimicking the ball, so they've both got one. So the easiest way we're going to do that is actually if we open up our target ball here, and we can just copy all of this information here, not the reference of course, and just Control C, come over to the boat and click Control V, like that. Say as we're writing all that over again. Okay, so what I'd like to do in here is a delay, and this is a delay to stop while the boat falls into the water and settles. We're just going to do a 4-second delay. Then you're going to do the same line trace. You're going to look for the landscape, the same depth. What we'll do is we'll make that depth a little bit bigger, just in case we have problems here. Break hit results the same, and we'll probably say line trace to not hit the landscape, and we'll say on the boat side, just so we know what's going on there. Okay, let's give ourselves a little bit more room here. So we're going to do the line trace, and then we're going to spawn the actor, and then we'll also promote this to a variable for the boat, and this is AI Pathfinder for boat. Okay, and then at that point we'll then spawn our target. Compile, save. Yeah, so now we are spawning the spawn the target. It's spawned the target, and we've now got to move to. So before we're moving to, we need to know the path. So we're going to take that move to out of there, and what we'll do is we'll move this out the way so we can reference that, and we're going to have a custom event, and this is going to be draw path. Something there. Custom event draw path. Okay, so what have we got here? So straight away we are going to have the current target, and of course we always need to check, is it valid? If it is valid, well, let's put our print string in here and say the current target not valid. Okay, so from this current target, the current target is the target ball. Now that's spawned in AI Pathfinder target ball. Okay, so now we can drag off of this, and we can now get that AI Pathfinder target ball. So this is the target that the ball has spawned. Okay, and we'll just double check, is it valid? Just so if anything's going wrong, we know what it is straight away. And then we'll do another print string, and we'll just go the AI Pathfinder not valid. Okay, and then we have got a node called find path to actor. Okay, now this is going to generate the waypoint from the two AI Pathfinder characters. So we want it to start at our, or the boat's AI Pathfinder, and we can get location, get actor location. This is where we want the path to start, and the goal is going to be the AI Pathfinder ball target. So we can drag off of there and put that into the goal, and we'll little reroute node there so we can see. And this is now going to return a value, but first let's always is valid. So did it find a valid path? Just do an if statement there, branch. If it's false, print a string, and we'll say no path found. Now at this point, to save you all some time and grief, if you're all following along, I'm just going to go here and say path has been found. And what we'll do is we need to go back to our spawn target, and we need to now call draw path, and it's going to run this line of code. So let's compile, save, play test, or process, wait for the boat to come in, and path has been found. So we know it's finding a path. If that's false, go back, double check you've followed correctly, and then come back to this point if you have got no path found, okay? So we know the path's been found. This is great. So we can now come off of there. And what do I want to do here? Yes, so we can now drag off of the find path actors, and you can pull off of here, and you can say get points, and this is going to give you an array of all the points along the path. This is brilliant. So now that we've got the actual path in an array, we can do a for each loop, leave a bit of space because we've got to put something in here in a second. So for each point on the path, we are going to spawn actor from class, and the class is Waypoint. Now, because we've done that little bit of code again in this Waypoint, it's going to spawn it at the point and then move it to 0, which is like the water plane level. So we just need to split the transform and drag off the location of the index of the array, right, which is the path. It's an array of the path points. So if there's 10 points, it'll for each loop, so it'll go 0, 1, 2, 3, 4. So for each one, you want to spawn in a waypoint actor at that location, and then we are going to promote that to a variable, and this is going to be waypoints. Okay, so we've now got that variable, but what we're going to do is we're going to delete that one, and in fact, yeah, we'll get rid of that one for now. Click on your waypoints, and we need to change that to an array. So click on the little drop down here, change that to an array, which is the 9 dots. And now we can drag that out, and we want to pull off and say add, and this is in the utilities array add, and you want to add this unit to the array. So we're going to have a new array of actors. Okay, now before you do anything like this in a for each loop, which you're going to do like recurring, you want to come before the array loop, and you want to get your waypoints, and you want to clear the array first, because it's going to add. So if you run this, you go to the first point, and then you create another path, it'll add these old points. It'll add the new points to the old list. So you want to clear the list, then add your new points to the array. Okay, and then when that's complete, so don't drag off of here now, we're going to come back and we're going to drag off the complete, and then we're going to call move to, and this is our move to function. And we want to double click on it, it'll take us up to here, and we're now going to want to add a new parameter of type AI Pathfinder object, click down, array, change the name to waypoints. Okay, so then we can drag in our array points, waypoints, sorry, not AI Pathfinder, we want waypoints, object type array. And now we can get our new array that we've added them all to and drag that into there now. So we can compile save. So we're going to get an error. Oh yes, that's fine. We'll get to that point in a second. Okay, so our new move to is going to be, we don't need that now. We don't need that. We're going to get from this, and we'll do we want to set them? No, we don't need. I've got some other code here of what I've done, but I've just realized there's a couple of things that was probably unnecessary actually, so we'll simplify that as we go. So we're going to get the first point. So 0 is the array index. 0 is the first one, then it goes 1, 2, 3, 4. It doesn't start at 1, it starts at 0. So we're going to get this first index, and then we'll get actor location. Okay. Now this actor location is going to be our new 2. Okay. So we're going to move towards the first point, and then we can reconnect that up. So it's going to look like so. So this will all stay the same. This will all stay the same. This will all stay the same. This will all stay the same till we get to the end here. So at the end, so after rotation, let's see what order I did things in here. So yes, okay, so at the end it does actually come back from here. So we're going to drag this down. So after the rotation, put another reroute node here. After the rotation, we want to do a branch. So we can come off of there, type if. And what we're checking for is, are we at the point yet? So we're thrusting towards this point. So we need to check every time we add acceleration, are we at that location? So the way we're going to do that is we're going to get actor location, and we'll want to know, is that equal vector equal to, yes, is it equal to the point that we're trying to go to? So it's this point here. Okay, so I will reroute that. So the actor location of the index 0, is that equal? And what I will do is I'll give that a 500 because the boat's quite large. So you want to be 500 worked for me for that boat. Okay. So if that is false, we do what we normally do. Except we need to add our waypoint back into the the waypoint in the move to node. Okay. Now, if we have got to that waypoint, what we're going to do is remove it from the path, and then just call the move to node again, and we're going to remove it like this. We're going to get the waypoint, get the index that we want to reference to, and then we destroy that actor. This is just visual. If when you're done with the debug and you don't want to spawn all the bones, you won't need to destroy it because it won't be there. So we're going to destroy it visually. But the important part, which moves you on to the next one, is you're going to offer that index. You are going to remove item. So utilities array, remove item. Okay, and that's from the array. Okay, and then we will do delay of 0.001, and then we will call the move to function again with the array points away, and that'll be without that first index, and then index number 1 will become 0, and 2 will become 1, and 3 will become 2, and so on and so on and so on. So now if we test, I think we can test. I think I've got everything right so far. So it has spawned a path, and the boat is now following that path. Like that. And as you can see, the avoidance, the reason we made that 1,000, because if we'd left that at 35, these points would be a lot closer to that point. In fact, the boat is still kind of hitting the side. So you could do one or two things there. You could either make the navmesh agent, the agent radius, bigger, or make your boat smaller. Either one's fine. But we have pathfinding avoidance on there. So that's what we'll call that for part 2. Now what I'll do in a part 3 is I'll do it a little bit more advanced version of this, so it will avoid other moving boats and moving parts, and it'll retrace the path every sort of, on a timer or something like that, so it can be more dynamic. So if things are moving around, it will account for that sort of thing, and it will also fix the issue where when you've got to that point, you can clear the old AI spawner, the AI Pathfinder, spawn a new one, and then from that location generate the new path. I mean, you could probably figure that out for yourselves, but I'm going to do a part 3 for the more advanced moving around, and I'll show that in that part. But alright, well, thanks for watching. Subscribe please, and like the video if you want to see more and you don't miss any more tutorials that I'm doing. And of course, if you want to join the Patreon, you can, and I'll put all these projects already built on there, so you can then just download and have a look at the actual source code on your own computer, and you can pull it apart and change it and do what you want with it if you prefer learning that way. Alright, well, thank you for watching. I've been Matthew Lonsdale, and the channel Coding at Home. See yous.